All right, so welcome back, and here's another LeetCode problem. So today it's called minimum size subarray in an infinity array. And so what we want to do here is, given our input nums and our target, what we will have is basically this array. The real catch here is it kind of expands to infinity. And so what you really have when you see 1, 2, 3 is it becomes more like 1, 2, 3, and then the cycle repeats. So then we have 1, 2, 3 again, and 1, 2, 3 again, and then it just kind of keeps going until infinity, so it never ends. And how that kind of causes a problem here is that because we want to find the minimum subarray that kind of adds up to this target, so what subarray means is, okay, what is a portion of this array that's contiguous or all in a row that has a total sum of all those numbers that equals this target? So we can see that right here. So 2 plus 3 is equal to 5, and that would have a total length of 2. So because it takes two numbers or two indexes here to get to that target, and in that case it's actually our minimum subarray. Where this causes a problem is that there would be cases where you would have to really expand this subarray to kind of multiple repetitions of this array. Like say you have to basically, say if this was like 5,000, then you might need like hundreds or dozens or whatever of this array repeated in order to get to that target. And because this is a minimization function or minimization problem, you would have to kind of brute force calculate every single subarray, their length, and which ones get to that target, which just wouldn't work with this kind of input size, okay, and the size of the target. And so you want to find a clever way to get past of the time complexity issue here and the space complexity issue of having to kind of brute force and try all these different subarrays, the size of that particular window for this infinity array. All right, so essentially I'm going to code it up in a second, but I want to kind of give you some quick hints here or tweaks and the main kind of catches or understanding that you need in order to solve this problem. And so the first thing that we're going to see here is this example. And so how you're supposed to solve this one is actually just repeat it once. So it goes 1, 1, 2, 3, and then we're going to see again 1, 1, 1, 2, 3. And so the minimum subarray in this case is actually 3, 1. And so in order to solve this one, you actually have to expand this array nums at least once in order to see this relationship that, okay, the final number and the first number in the sequence or in the array would actually have just a window size of 2. And that's actually the minimum in this case to sum to that particular target. Okay, so you actually have to expand this one to see that. From here, so how do we get past that time complexity issue of having to kind of brute force all those solutions? So a common one, especially when you're having to repetitively calculate the sum of something, is use something called prefix sum. Often, if you want to do the inverse of it, it's called postfix sum. So just to quickly explain to you what that is, if we're given, say, this array as our input, what the prefix sum of this would look like would basically be 1. So we basically have a running sum. So initially the running sum is 0, but then we add the first one, and this is going to be an array. So it's like prefix sum array. So we're going to add 1 because we're initially looking at the first one here. And then we move to the second one, and basically we're going to add. So now our running sum is 1, and we're going to add 1 again. So now we're at 2 for a running sum. Now we're going to be at 2 here, and then we're going to add 1 to this running sum, which is now going to be 3, and so forth. So now 2 gets added to 3, which is now 5, and then now 8. So basically we start at 0, and then as we move along here, we're basically adding up. And so we can kind of see here what we call the running sum, or the sum so far of all the numbers that we've seen. Okay, and so what this allows us to do is kind of understand of, okay, if we used all the numbers within this range, what would that sum to? Which is really useful when we're trying to find what range of numbers we need to sum to a particular target. Okay, and so the other catch here that's really useful with prefix sum is, okay, what if I want to just know, not just from the first index, but what if I want to find out what the index is, like, say, from this point here, right? Or say this point here. So to figure that out, all that you would need to do is say, okay, if I want to find out what the sum of the numbers is between this range, all that you would have to do is essentially just subtract the numbers from this range. Okay, so we would see here that it's basically just 8 subtracted by 3 here. So 8 minus 3 would give us 5, which is, yes, that's true, the sum of 2 and 3 here. And so that is really the power of prefix sum. And so from this point on, there is one other edge case, which this was in the most recent LeetCode competition, and I was so close to figuring out, but it was really this catch here that I wasn't able to do. Okay, so it's really important that you kind of ingrain this in your mind and understand here, and I'll try my best to explain it, what the challenge is here. So essentially, what we have is when we have a target that's like 40, that's much larger than the total sum of this input array, right? Because this total sum of this input array is, I believe, 8. Yes, but 40 expands beyond that. And really, I'm going to add maybe say something like 43 is what we need, let's say. And so in order to get this, what you would actually need here is minimum, if this is 8, we would need minimum 5 of these entire arrays here. And so a quick way of doing this is instead of expanding the entire array, we can just say, okay, instead of having a target of 40, let's instead just look for 3, because we know that we just need 8 of these input nums, which will have a length of basically 5 times 8, or sorry, yeah, so when you want the minimum size, we already know that we need 8 of these, and so we just do 8 times the length of this in order to get it. Or I believe, no, we need 5 of these, sorry. The sum of this is 8, so we need 5 of these. And so what we say is, okay, the minimum length that we're going to need is going to be at least 5 multiplied by the length of this, so the length of nums, which is basically just 5 times 1, 2, 3, 4, 5, so 5 times 5. So we're going to need 25 characters to at least get to 40. But from 40, we're still going to need 3 more here. And so in order to figure that out, and I'm going to use a different color because this one's getting faint, we're going to say, okay, we already know that we need 25 or at least 5 windows to get to 40. And so now really our problem isn't 40 anymore. We're now just trying to find 3. And so now we just have to say we know that we need that many windows, so 5 windows to get to that point. But how about calculating 3? And so we minimize the amount of calculation that we have to do. We just now have to find a target of 3 here. And so what you now see is that, oh, right here, this would be the smallest one. All right, this would be the fastest way to get 3. However, what we're going to imagine here is something like this, and this is like the true magic of it, is that, okay, what we saw was that we have the input array, and I'm just going to erase this all, but we're still trying to get a target of 3, target equals 3 here. But what we have here is that, okay, this array expands infinitely, so we have 1, 1, 1, like so, 2, 3, then we have 1, 1, 1, 2, 3. And so what we really want here isn't to start, and I know we said that we want 5 windows, but we're going to start those 5 windows basically here at this point onwards. And it's going to continue on kind of until we hit that 40 windows. So we basically want to start the subarray at this point and then plus 5 nums, or 5 windows, I like to call it, like the sliding window pattern. Okay, so it's going to take 5 number arrays plus starting at this 3 to get to the minimum size subarray. All right, and that's the true catch here. And so in order to get that, I'll show you programmatically how we solved to get to that 3 here, but essentially all that we're doing is what I told you with that prefix sum, is we're just figuring out, okay, it's basically going to be this minus this portion here. All right, so we'll go ahead and go to the coding implementation, but I think this is enough to kind of keep you going and get the logic in your head of how we would approach this question. All right, I'll see you in a second. All right, so welcome back, and let's go over the actual implementation of this. So essentially what we're going to want to do here is first figure out how many window sizes or how many of these arrays do we need to use to kind of build up to our target. And so to do that, all that we have to use is something called div mod, which is just saying take the division and the modulus of a particular number as well as the denominator there. And so that's just going to look like something like this. So we have our particular target, and we're going to divide as well as mod by the sum of these numbers. And so this is just going to spit out our window size and our new target that we're trying to obtain. So we know we need at least this many windows, but this is actually our new target here. It's just a way so that we don't have to have this huge kind of time complexity of having to solve for the entire array. It's just a really quick and clever shortcut, so you don't have to build and construct that entire infinity array to get to our solution. All right, and so with that, we can just say, okay, well, we're going to have to use the length a few times. So just for simplicity, we're going to put it here. And with this, there is one catch where, okay, what if our new target is 0? Let's just go ahead and return basically the length of the number of window sizes that we need. And this is just that, okay, what if we only needed one array and the sum of that array is our target? Then that's our solution. Or say we needed 10 of them. Regardless, we don't really need to use any partial portion of our array itself to find the minimum length. All right, and so with that, if that's not the case, we want to continue forward and find some subarray within our overall infinity array that has this solution. So we're going to return that result at the end, this minimum result, or this minimum length, but it's going to start at infinity because we want to start the largest number possible and kind of shrink down from there. And it's just a typical LeetCode pattern that we see a lot. And so with this, we can say, all right, we're going to want to store these prefixes that we have that I talked about earlier in some data structure. And so we're going to use a hash map here. And so we'll just call this prefix. And so what the key and the value for it will be, will basically the prefix sum mapped to the particular index where you can get that prefix sum, so the index location. And I'll explain that in just a second. Excuse me. But the typical pattern that we see for prefix sum is something like this. So we're just going to enumerate through these values. So enumerate our nums array here, like so. But with that, we're actually going to multiply it by 2. And this is just a case where, what if we have something like this? We have an array like so. So we'll just duplicate it one more time just to show you the infinity array. But say our target is actually 4. And so in this case, what we want is this kind of subarray here. But you can only see that if you at least multiply this by 2 ones. And so we're going to do that to kind of handle this particular case here. All right, and so with that, and I think that's a very clever thing, and so you should really pick up on that tip because you might have to use it in a future problem here. And so what we're going to do is we're going to keep track of a running sum, and this is just part of this prefix sum algorithm. So it starts at 0, and so as we go, this running sum will be increasing by the number. And so now that the new kind of prefix or the difference that we need will be changing over time. So the number or the difference that we need here is basically going to be the target minus this running sum. And so basically if this number that we need is in our prefix, then we might have found a new minimum here. And I'll explain this further in just a second when we go now. And so basically what this represents is, say that we have something like 1, 2, 3, 4, 5. And say we're trying to get the number, let me think here, like 7. And so if we want the minimum length for the number 7, what you can imagine here is we build all the way up to something like this point where the total sum of this, and we're at index 0, 1, 2, 3, so this is index 3. Then we have, okay, the total sum is 7, so 10. But what we want here is the minimum subset that sums to this target. And so we kind of want to subtract from here 3. And we've actually seen that before, and it would be contained within this prefix sum hash map, which is this portion here, starting at or ending at index 1. And so all that we would look up in our hash map here is, okay, do we have the value 3? Yes. If so, what's its index? And so what we want to spit out from here is our new result could be basically index 3 minus this particular index, so we can get basically the length of this new subarray, right? So I hope that kind of clarified things there. And so all that looks like is basically what's the current index minus that index stored in our lookup here. And other than that, with each iteration, naturally we're going to be appending this new running sum that we're currently at, like so, in our hash map here. And just one other edge case is this one. And so this just means that because in Python it's 0 index if we're starting our window at the very beginning there. And so we're kind of doing a lookup for 0 because the number that we need is basically going to be nothing because our running sum will be our target. So what do we need? We need nothing actually. So just to handle that case, you have to have -1 just to deal with how it's a 0 indexed language. All right, and so with that, just to be true to the constraints here, if we get infinity or we're not able to actually get a result, we want to return -1 instead of infinity. So we just say, okay, if we want to return -1, if this is equal to infinity, otherwise we actually want to return that result there. Let's go ahead and run it. Oh, I forgot to colon. Let's see. Let's take a minute to run. Let's try refreshing. Oh, what do we got here? We say -1 when we shouldn't be, so the running sum is at this particular index. The result is the min. Oh, we definitely want basically running sum minus our target, like so. So let's try running that. Yes, accepted. Sorry, I just had it inverted because the running sum will be greater than our particular target. Whoa, this is a very much later case. So if our target, and then the sum of the numbers, that's the length. That looks good. I just have my notes above me. Let's just see what I did wrong here. Oh, and that's just because, well, we're outputting our result here, but we're wanting to include how many windows we needed to build up to it. And then this is our leftover target that we need. And so we just have to say, okay, yeah, this portion here is still true to us because we still need this many windows to build up. And then what's like kind of the spare change that we have to account for? Well, that's going to be our result here. So I don't know why it's so slow right now, but let's try running it. And accepted. Sorry about that little complexity here. So just to reiterate, essentially this portion here is just to calculate on top of the number of windows that we need from this infinity array, or the number of arrays, the full array. This is kind of like what I call the spare change, or the leftover amount that we need to kind of pick out where does this subarray really begin in the overall infinity array. All right, so I think that's pretty much it for now. I hope it helped a little bit. I think me reiterating with you really helped myself as well. This was a complex problem, but it really expands upon prefix, such a simple concept. But when working with some of these edge cases here, it can be tricky, as well as just figuring out some of these catches where you want to look at the size of the array times 2. But I think the main concept here is that you can really apply just anywhere as possible is at times you don't have to calculate the entire infinity array itself, but simply what is the spare change that I really need to calculate, and just getting the total sum of the numbers, and that just greatly reduces the complexity of your algorithm. All right, so yeah, thanks for watching, and good luck with the rest of your algorithms. See you later.